Sir, ஆரம்பிச்சலாமா? So good evening to all of you. I welcome all of you for today special lecture program. That topic of today lecture program is Kickstart Your Career in Mobile Robotics. Behalf of IEI TLC, I welcome today's speaker, Mr Muthu Vengaliappn.
Anand,
Yes sir.
one minute, கொஞ்சம் முதல்ல ஸ்டார்ட் பண்ணுங்க, நான் ரெக்கார்டிங் ஆன் பண்ணல.
சரி சார். ஓகே சார்.
Tamil chairman is not ready. Good evening sir. Ramdas sir, good evening.
Good evening.
Good evening, Ramdas.
Sir, ஆரம்பிச்சலாமா சார்? ராம்தாஸ் சார்.
Okay, go ahead.
So warm good evening to all of you once again. So I welcome all of you for today lecture program. That topic of today lecture program is Kickstart Your Career in Mobile Robotics. On behalf of IEI TLC and my own behalf of, I welcome today speaker Mr Muthu Vengaliappn, CEO and co-founder Catamaran Technology and Business Solution. And I welcome all other senior members from our IEI TLC and CSI CSI chairman and Tamil Nadu State Center chairman and Mr Kannan, honorary secretary, Tamil Nadu State Center. Sir, good evening to all of you, sir. So now I request our chairman, Mr. Dr. Engineer Dr. Kumaresan, to give presidential address.
Good evening to all of you.
Good evening, sir.
I join with Engineer Anand to welcome you all once again for today's talk in the online mode. So due to the COVID-19 pandemic situation, many aspects of our lifestyle or living standard changed. Every one of us are very much conscious on social distancing. Most of the activities are online mode. This is not only safeguard self, but support others to fight against COVID-19. In this regard, robots will also assist and support to cope up the present situation. Hence, Institution of Engineers Tiruchirappalli Local Center, in association and jointly with Institution of Engineers Tamil Nadu State Center and the Computer Society of India Tiruchirappalli chapter, arranged a technical talk on Kickstart Your Career in Mobile Robotics. So today's speaker is Mr. Muthu Vengaliappn, CEO and founder, Catamaran Technology and Business Solutions, will deliver today's talk. Thank you, Mr. Muthu, for accepting our invitation gracefully. And once again, welcome you all for attending this program in the online mode. Thank you.
Thank you, sir. Thank you for your presidential address. Now I request CSI Tiruchirappalli chairman, Mr. Selvaraj, Engineer Selvaraj, and he is our former IEI chairman. So I request him to give a brief introduction about speaker. Sir, unmute பண்ணிட்டு பேசுங்க.
Okay. Now I am audible, I think. Okay. Right, sir. Thank you. Happy good evening to everyone. Happy good evening to the chairman, present chairman, Dr. Kumaresan, Swamidar sir, our Tamil Nadu State Center chairman, Mr. Ramdas, Mr. Kannan, new secretary. Welcome you, sir, to our Tamil Nadu State Center secretary. We are very happy to will be associating with you. I very happy to say good evening to Mr. Muthu Vengaliappn and also all the participants of today, our members, others. I am very happy to introduce today's speaker, the chief guest of today, Mr. Muthu Vengaliappn. He is a CEO and co-founder, Catamaran Technology and Business Solutions. His objective is energetic individual intended to create a better world for the next generation of humanity with the help of technology. Education. He has done MTech in embedded systems from BITS, Bilani, Rajasthan with a CGPA of 8.58 in 2019. He has done his BE Robotics and Automation Engineering from the PhD College of Technology, Coimbatore, with the CGPA of 9.23 in 2015. The higher secondary education he did in Tamil Nadu State Board with a 95.16 in 2011. Secondary education under the Central Board of Secondary Education with the 88.8% in 2000, is all with flying colors. With work experience and internships, that is founded and working as a chief executive officer in Catamaran Technology and Business Solutions from December 2018. Worked as an associate and senior engineer in robot Boss Engineering and Business Solution Private Limited for a period of 3 years and 6 months. Summer internship for a period of 6 weeks in ERTS lab, IIT Mumbai. In plant training, he has done at Puma Forklift Private Limited for a week period. Company summary: Catamaran Technology and Business Solution is a young startup founded in 2018, which mainly focuses on product development on artificial intelligence, Internet of Things, robotics, enterprise software development. Below is their expertise, that is artificial intelligence, machine language, computer vision, video analytics, text analytics, natural language processing. And the IoT Internet of Solutions, Industry 4, Environment, Industrial, Internet of Operations. Then Robotic Solution, Industrial Automation, Guest Interaction, Robot, Patrolling Robots, Native and Cross-Platform Application Development in iOS, Android, and for Windows, Mac, open source, and Linux using Electron, website design services capabilities including responsive designs, parallax design, UI and UX consulting, JavaScript technologies including Angular, Backbone, JS, Node, JS, React, Python, PHP, Ruby-based projects, C++. Technical strength: there is a mobile robotic using ROS, IoT and embedded systems, system and process automation. Personal achievement: his personal achievements are founded Catamaran Technology and Business Solutions along with 4 of his fellow batchmates. In the span of 12 months, our team rose from 4 to 22 in count with an annual turnover of around 50 lakhs. Now they have the client presence in 3 countries, that is Singapore, Oman and Italy. Received NIDHI Trias, supported by Department of Science and Technology, Government of India for funding of 8.6 lakhs from PAG STEP for the product Windmill Watcher. Currently, they are incubated in PAG STEP and Forge, that is KCT Tech Park. They are in the Startup Alliance with a Boss DNA Develop Nurture Allied program, awarded the Best Young Alumnus Award for the year 2020 by PhD Tech Alumni Association, received a RAE Startup Award from the Department of Robotics and Automation Engineering, PSC College of Technology in the eve of ICC AIRS 2018, holding patent and apparatus for testing touchscreen devices application number 2011-04-1029-5464, awarded the Best All-Rounder of the year 2014-15 by PhD Technical Alumni Association, won national level second prize in the E-Yantra 2012 and E-Yantra 2013 organized by IIT Mumbai, funded by Ministry of Human Research and Development for developing the room cleaning prototype and fruit plugging prototype. Passed out with a first class and distinction in undergraduation program and first class in the post graduation program. So with this introduction, I request Mr. Muthu Vengaliappn to go ahead with this program. That is delivering his topic. Thank you, sir. Welcome, sir. Please.
Thank you, sir. Thanks for a warm introduction, and it's been an indeed honor. Like I was speaking with Samida sir, and he connected with this chapter, and maybe once we met in PhD Tech long back, and that made this association, and finally I'm here to deliver. So thanks for the invite, sir. So actually, maybe all are very senior. Maybe I'm the one who is the least age here. Thanks for maybe the title should be something different. It should not be kickstart your career. It should be something different. So maybe okay. So actually, the main agenda of today is to deliver content where we actually the slides what I have prepared and what are the slides which I'm trying to present are all the real use case which we are facing currently. Like actually almost we started this company around 2018 in a full-fledged mode. Even before we started this company as a startup, registered as a startup, but we are working as consultancy and other things. But as a product development company, we emerged as a product development company since 2018. From then we started developing service robots, mobile robots. Actually our main agenda is to develop mobile robots for various service industries. So that was our first initial step step again, towards this. So based on this, we started developing few robots. So what are the lessons I learned from this robotics by building these robots? What are the mistakes we made? All these things I put it into slide so that we can maybe so that no one will not repeat this mistake again back. So it is like just an eye opener. If you are new to this service based industry, I mean service robots or mobile robot industry, so this should be like it will be like a starting point from where you can start this, and that is what my intention. I wanted to set some context how to start a service based service robot industry or a mobile robot industry, where maybe how to select components. It is like starting from R&D to a full-fledged product. Maybe I have put whatever the experience I have, what are the mistakes we have done. We have selected those things I have consolidated into a slides and I have prepared for today. So I let I will be presenting the slides in middle. If you have any doubts, please stop me, and then we can stop at any moment and we can discuss it, and then we can proceed further. Because waiting for last will not maybe this. I want this session to be like these are like lessons learned sessions. Like we can share our experiences so that it's become more fruitful and more interactive. Maybe I am very interested to learn from you as well, because all what people I'm seeing here are more senior peoples and experienced people. So I'm very open to take your suggestions as well in all wherever I require. So maybe without delay I will start my presentations. One minute, I'm sharing the presentation. Okay. Okay, I think. Okay. So I think you are able to see the screen, right? So yes, I'm going. So kickstart your career in mobile robotics. Actually, this is mainly the focus is to there is an untapped market in a mobile robotics segment. Mostly we see robots are used for industries and other purposes currently, but there is an untapped market or a grooming field where it is a service robots. The service robots would be the next gen field where most of the robot industry would fall. Like there are several industries already, the well-versed industries like Tesla, Honda have already have their robots in service robots. So maybe this is like I wanted you to give you overview how this what are the options that does a service robot have in today's segment. So that would be our point. So the service robo, maybe ISO, what is the service robo? Before going into what is the market segment, who is a leader, and what are the things constitute service robo, before this we'll go for a definition. As ISO refers a service robo that performs a useful task for human or equipments, excluding industrial automation applications. So this is what we wanted to target a segment which is totally out of industrial automation applications. So for industrial automation application, we see there are n number of vendors or n number of players who do a lot of services for doing automations. In this field, there is an untapped market in the context of service robotics. That is where we wanted to address today, and that is where we focus as a company from as a company in Catamaran. We focus on the service robots. So maybe 1 minute. So actually, according to market strategy, this is CAGR 22.6% from 2020 to 2025. So which means that there is a good growth rate in 22.6%. Means this is a segment where we see a good growth, and there is an upcoming. There are a lot of opportunities in this industry. So only 1 minute. Okay, so here we expect around there is a 37 billion USD. The market worth is 37 billion USD, and which is expected to grow by 22.6%, which is around 102.5 billion in 2025. So this is where we see the service robot industry is growing, and this is where we see this. This is where we see our opportunity. So maybe 1 minute. So finally, before going into this, where do they exist? Like what are the segment or where are the services areas where these service robots can fit in? So the domestic, already if you see there are every people started making floor cleaning robots, lawn moving, pool cleaning, and others. So mainly, if you see, almost all home appliances industry, starting from LG to MI, they now deliver floor cleaning robots. So that is where they can penetrate into a lot more homes. So that is actually that is already an exploited market. We call it in startup field or something. It's a red ocean market. So almost all the market opportunities has been explored already. So already there are more big players. There are huge sharks playing in this ocean. So as a startup or a small company penetrating into this space would be a little more difficult. We have to go with the innovative products. So already the domestic market has been exploited. Since in the medical industry, if you see more in medical part, the medical aspect, you go for a long certification process, long investment, and long other certification. Other than development, you need to trials and testing things to go for a very long time. So that is where the medical field is little untapped, and there are only very few robots which do autonomous operations and other things. So these also we call it as a service robots. So next thing is agricultural. Being an in India, agriculture economy is good, but the willingness to pay for an robot or for an autonomous product is a little low in India. So the agricultural market opportunity is also little low when compared to other segments. So next thing is logistics. Logistics is a warehouse automation. It's a last mile delivery. So I'm not focusing on the industrial automation part. I'm focusing on the last mile delivery bots and other thing. Maybe we'll discuss this thing in near coming slides. And the third and the fifth thing is entertainment, education, and personal assistant. So which is the field which is growing rapidly, where people adopt a lot of entertainment robots, educational robots, and they go for personal assistance robot, which is a grooming field where we see a good market scope across globe. So maybe I'll see 1, 2, 3. When compared to 1, 2, 3, 4, and 5 are good field to invest. Maybe with your context, it may be the good field to invest, and it may be the good field to where there is a good market scope and there is a good opportunity in the near futures. So I see logistics and entertainment, education and personal things I club together. So that is where we wanted to focus next thing. So here I have some videos to show you, so that how maybe we can say service robots, no? So how they exist and what are the some fancy service robots currently exist. So 1 minute. Actually, this is a Caro Bot 4 from Hanhover. So these are like a personal assistant robo. And next thing I wanted you to show is this is one of our robo, which we have deployed it in one of the restaurant in Raipur. So this is what the robo which we made, and this robot's background is like it's a magnetic tape follower, and it is little autonomous. Now we are into the field of doing autonomous. Actually, this robo has been like 1.5 years. It's around 2 years now. So these are the few robots which we deliver. Maybe we have delivered somewhere in Kerala as well. This is one of our robo which we deployed in Raipur, Madhya Pradesh. Okay, next thing is maybe I want you to show how foods are delivered. Maybe this is one of the food delivery robo, which is currently revolutionizing. Maybe we'll have a look at it.
Mr. Muthu, audio is missing. Video
You're
is
not.
coming.
Oh, you're not able to hear the audio, sir. Actually, I thought of
Yeah.
checking.
Yeah.
Maybe I don't know how to include audio.
No, it's not. It's fine. No, not the issue.
Maybe, sir, 1 minute. No, you're not able to see the screen, sir. Okay, maybe I'll. Okay, I think audio is not hearing, sir. Maybe I'll go through what actually I will do a.
Sir, screen is visible, Mr. Muthu.
Yes, sir. Now audio is not here.
Audio is not
Audio
able, sir.
also
You can
okay.
explain, sir. You can explain. Go ahead, sir. There's no
Both
problem.
are okay, sir.
Okay. Actually, sir, I wanted to show you this robots. Actually, what are these robots? These robots are mainly for a security purpose industries. These robots, they use it for security industries. Now, actually, in most of the countries, the finding a security is more difficult, and most of the security industries require skilled labor. Not like a in most country, security industry is a certified industry. It is not like us people like employing a security here in India. So one of the problem we are solving currently is for a security industry at Singapore. We are also kind of delivering a similar kind of a robo for Singapore industry currently. Maybe this is not our robo. Maybe this is from a night scope already a existing company. This company exists for around last 3 to 5 years. They have supplied around 100 plus robo across globe. So the agenda maybe this is they mainly use it for security industry, and this is one more robo we call the SMB robo. So this robo is also a similar kind of robo. Maybe I'll play a few videos. So this robo operates on a without lidar or any high-class sensor. This robot operates based on the video data, and this is mainly used for video surveillance. We are maybe as a catamaran company, we are into the segment called video surveillance. Normally, the CCTV cameras are used only as an evidence. Currently, they are not used as an alerting system because after a theft is done, CCTVs are used only as an evidence. Because of which there is nothing is going to change in the world. So it is we have to alert while the theft is happening or something is doing. So currently we have what our main business is like. We have adapted around 10 to 15 condominiums in Singapore. That is, a condominium is nothing but an apartments in Singapore. So these apartments, we take the whole building control starting from their CCTV. Like we have around 60 to 70 CCTV cameras per buildings. So we control all those CCTV cameras. Like we take the feed in and we'll pump this data into our clouds. So our cloud will take a necessary action whether there is an alert. Say it can be an illegal parking. What are the vehicles coming in and out, and if there is a garbage dumping, if there is fire alarm, or if someone has parked a car for a long time in a no parking zone, or if there would be some zone called pickup drop off zone, there we have to spend, they have to stay only for 15 to 20 minutes. Beyond this they are not allowed to stay. So those kind of alert.
I'm not doing work till now. I'm doing work till I'm going, sir.
Okay, so those data we will be able to alert the security and provide the real-time alerts. So we are enabling the security with the technologies, because you need not to have 10 to 15 securities to roam around always and ensure that everything is going in place. So what we provide is, we provide an alerting solutions where security can go and respond immediately. In those cases, instead of a security, a robot autonomously goes there and alerts if the security is not there. So this is how we are trying to solve the problems, and this is how we are going to address the scenarios. So maybe so far whatever I have shown is, there is a industry, maybe we have never thought a service industry for securities, or service industry, a service robot for food delivering, or a service robot for a personal assistant, or service robot for a food delivery. These are the things which are products of the last and this decades. I mean, around after maybe in a decade back, we would have not thought of this robot for this kind of applications. So this is an era, or this is a decade where we are looking for this kind of solutions. So here the next thing is, I want to show what are the components really used in this. Let us do a post-mortem of this robot, so that we'll understand what is really present inside a service robot. So instead of simply going beyond the technology, or doing beyond the fascinating things, we will understand what this technology does behind, or what is inside this technology. So that is what I wanted you to show, and that is where we can discuss more on how things happen. So the main thing is batteries, and the next thing is motor drivers, motors, encoders, wheels, controller and processors, IMUs, so BMS charging circuits, cameras, depth cameras, lidars, ultrasonic sensor arrays, GPS, microphones, speakers. So I think I have put most of the components which are available in this robots. So we will see how to say, for example, if we say motors and motor drivers, we can have n number of motors and drivers. So here the next few slides, or next few set of segments, what we are going to discuss is, we are going to discuss more about how to select the motors and what are the parameters you have to consider while selecting. So this would help us to kickstart, like maybe if you are starting, or if you have an idea to do with some patrolling robot, or service kind of a robot. These are the some insights or some points which I wanted you to give you, to make sure that you don't make mistakes, or this would be just a helping guide, because whatever I'm showing here and whatever the selection methods I have used are all, like when I started the service robot, even though I have studied robotics and automation engineering, when I started this robotics as a startup, we find that we made a lot of mistakes. Even we actually, whatever the theory teaches in colleges and whatever theory teaches in books does not apply to the practical products. So in those times we faced a lot, we failed a lot, but we are able to now deliver a robot which could do different applications currently. So that is what the next few slides will explain you what are the things to be taken into control while selecting this. The core part is controllers and processor. These are the deciding elements. So normally, what is the controller and processor? Normally, what we do is, we do start with Arduino or start with microcontrollers, but that will not yield up to a product. So better start with the processor. So starting it with the microcontroller and moving to a processor will consume your huge amount of time. So first itself, start with the processor. So next thing is, ROS-based platforms are easy to manage, because ROS is nothing but robot operating system. This is already a framework which is running on Linux, is able to do almost everything which is necessary for a mobile robots or any robots. So these are like an architectural framework which has publisher subscriber model. Maybe if you are more into software, I can give you detailed about ROS. Maybe as of now, I'll move on with just a basic definitions. So ROS is nothing but a robot operating system. It's just a framework running on Linux platform. So mostly this ROS itself takes care of a lot more things like matrix multiplications, visualizing the sensor data through robot. Actually, the ROS helps us to visualize the data with robot's eye. I'll say if you're mounting a lidar, automatically if you just give the position of lidar from the base or the center of the robot position, automatically this lidar data, whatever the data which the sensor gets, is already manipulated and converted into with the perspective of robot. So lot more things, like we'll see there are some simple things which may take more time. So these things are made easy for you and you can straight away go into this, and there are huge support. Currently the ROS is one of the growing platform where you find a lot of supports, like almost every sensors which are available in market, they already develop a package and they give it to you, so it is easy to fit in. So here you need not to invest more time on converting the data into an useful informations, converting the raw data from a sensor into useful information. So already the ROS packages are available in open source, so you can take that and you use it. So here next is what is the controller and processor. Okay, we'll select the processor. Now what is the processor you have to select? So the next thing is the processor can be Pi 0 to Intel i9. So Pi 0 is the least processor. I mean, Pi 0 is nothing but the Raspberry Pi 0 version. So it's the smallest computer. So with that, you can just minimum you can control the motors and other things. But when you go with Intel i9, you can incorporate all the video analytics capability. You can incorporate 3D lidars and what the computation capability. So the computation capability increases from Pi 0 to i9. That is what I have put the two extremes. That is a Pi 0 is the minimum version which I have seen so far, and Intel i9 is what maybe now i10 has come in place. So i10 or i9 would be the last highest processing power capabilities. So next thing is peripheral support and interface must. Actually, the peripheral support in sense, it should have a good peripheral interfaces. You should not select a controller with lower peripheral. Say it should at least have an USB and Ethernet interface support, so that you are more comfortable and you are more flexible while interfacing the sensors. If you purchased a processor without any support or peripheral interface, you will not be able to interface the sensors. So that is what I'm saying. The interface, the peripheral support interfaces must. So make sure that you buy a development board, not a module. There are say for example, if you're buying an Intel i9 chip, so Intel i9 chip is a separate IC. Don't buy that and say that is a processor. Buy a development board with the peripheral interfacing circuitries, so that you don't waste time on preparing those interface circuitries. So this would be an easy step to go further. So these are the few mistakes which we made, like buying a low power controller and we thought that would fit into our application. Then we migrated to the next processor. Then we found that some more things we need to add. So then we migrated to the next processor. So we were starting with Raspberry Pi. Then it moved to Jetson NVIDIA to Jetson TX2, then we moved to Jetson Nano back, and then from Jetson Nano to now we are into Intel NUC with i7 capability. So these were the like we jumped it across and we wasted most of the time. So that is what please make a note of the calculations prior and then start this operations. Okay. So controllers and processors. So next thing is how to select. The next key element is if you say this is the brain, then the actuators, then the hands and legs would be the motors and drivers. So how to select the motors and drivers? So please go with the PID supported drivers. Don't we can think of buying a low cost driver and then putting into this, and then don't waste more time on this, because PID supported if you buy a ready-made off the shelf PID supported drivers, they would be able to make your work easier. They appear to be costlier, but when you calculate the R&D cost involved in making a driver into a PID thing, this would be consuming your huge time. So that is what I'm saying. Please go for a PID supported drivers which are available in the market. Buy off the shelf, and the better thing would be communication based control. Just if we say set speed 1000 RPM, it has to set, instead of sending a continuous pulse or making to wait in a thread and sending continuous commands. So I prefer communication based control would be a much easier task than sending pulses and making your motor control. So next thing is feedback through encoder must, so that when you go for a robotic application, the localization is one of the key important thing. Localization is nothing but localizing your robo in an indoor space or outdoor space. If you're going for an autonomous navigation, make sure that the robo it's get positioned in a known space. When you know the current position, then only you can go to the next position. That is what, if you know the from position, then only you can go to the to position. Without knowing the from position, we cannot go to the to position. So everywhere when you wanted to localize these robots, you require a feedback from the external environment. That is, feedback through encoder is must. That is, feedback from encoder, you have to take the encoder readings, and then that is what converted into an odometry. We call odometer, maybe I think you will know about odometer, but odometry is the term which we use in robot operating system. So odometry is nothing but it knows how much it has traveled from its origin or from its start. Say for example, if you're starting at some origin position, and then if the wheel is rotating, and if you're moving somewhere, if you're moving with some constant velocity, based on the RPM count and the encoder pulse, it knows the wheel diameter, and then from those data we can be able to calculate where is the current position of the robot. So with all these things, so the encoder is must, because the wheel odometry is the main agenda or main key element which is contributing to the feedbacks. In spite we have a laser, in spite we have other things, wheel odometry is one of the key source for feedback. Okay, so calculate your motor spec. So while doing a calculation, please, most of us would just buy this by seeing only the stall torque, not by the running torque. Most of them we will buy stall torque, because the main mistake what we do is they will give you the torque capability. So that is a holding torque. That is the torque when suppose if the motor is at rest, what is the force you require to move the motor when it is at idle condition, not at the moving condition. So if you see the speed torque characteristics, the speed torque characteristics for different motors will be it will be different. Say for example, I'm considering a stepper motor, the speed torque characteristic would be drastically down. So in those cases, at very high speed application, you will get a very nominal torque. So in those times, whatever pulse you are giving in, the motor should respond. If it is not responding, or if the torque is going or the motor is slipping, then you are into a deep trouble. Like the getting and calculating the error things and then bringing back the things. Even though applying a PID, on top of this, if you apply another one PID, then total 2 PIDs will get collapsed and you will be into greater troubles. I'm not saying that is not a problem which we cannot solve. I'm saying those problems are difficult to solve, and it will consume most of your time, and that will slow down your R&D and slow down your progress. So the thing is, calculate your motor spec based on the speed torque characteristics, and then buy a motor which fits for the speed torque characteristics. Normally, for high speed application and high torque application, go with BLDCs and servo motors. Don't go with stepper and DC motors. So this would have a there at higher speed there the torque would have been less. So the recommendation would be BLDC and servos, and there would be some bigger calculations like inertial calculation, moment. At least it is expected to be done, but as when you start your career, don't get more time or don't put a more effort on calculating the inertia and other things. If you have a CAD model already, would have been an inertia. So just apply the basic inertial calculation and then try to calculate the torques and the speed requirement. So simply apply the basic physics. Don't get afraid or don't put larger formulas, and you need not waste more time on this. So just apply the basic physics which we have learned in maybe it should be an school, maybe it should be up to whatever formulas which we have learned till 10th to up to 10th or 12th would be the sufficient. Even we don't want any engineering formulas to be put on it. So the basic physics formulas would be much more helpful in calculating the motor specs. So at least don't the suggestion would be like, don't buy the motors upfront by saying that it has met the speed torque characteristics like that. So just do a basic calculation and ensure that it goes with your requirement and put a factor of safety 1.5 would be to be in the safer zone. Okay, so these are the few hints and a few points which we wanted to select during the motors and drivers, because one time what we did was by seeing the cost and other things, we bought a local motor which is available in India. They call the step servos, like the stepper motor with the closed loop all feedbacks with the controller everything. So this was running perfectly fine in a tile surface. So all our experiments, all our testing we done in the tile surface. But when we took this robot to Singapore and we wanted to demonstrate to a person over there or to the university over there. There we wanted to show the demo on a cement pavement and tar roads. So in those times, our motor drastically failed. Even the same application at high torque with high speed at height, even the smaller amount of torque, it was not able to satisfy, because of which we failed drastically, and we brought back the robot to India, and then we rectified all these things, and then we supplied a new robot uh, to Singapore again. So these are our learnings. Like we not buy any servo motors, stepper motors. We are going for a BLDC based servo motors, so which is almost doing half of your things what you wanted to do. The communication based control, say for example, you want to set the speed to 2000. If it is setting at 2000 and ensuring that it is at 2000 with the PID, then most of your work is done almost. So don't, because spend more on motors and controllers, because they are the most vital part of this robots. So next thing would be depth cameras and lidars. What is this depth cameras and lidars do? Actually, the lidars, I think most of us would know what is lidars and depth. Maybe I'll explain if there is someone. So lidars is nothing but the laser beams. These laser beams would travel 360 degree, and then it maps your point. So it gives you the 3D plot. There are two types of lidars. One is 2D lidars and one is 3D lidars. 2D lidar is nothing but it gives you the slice. Maybe if you cut your cross section of your home or cut your cross section of your house, the cross sectional point, the one slim layer, will be captured using 2D lidars. Whereas in 3D lidars, you capture the whole beams. So normally these 3D lidars are used in autonomous navigations, maybe the autonomous driverless cars which are coming in, right? So these cars use 3D lidars. So here is the one of the critical part, because all these components are little costlier. So making any faults or any mistakes while selecting would cost you much. So that is why we have to make wise combinations. So here depth cameras, 2D lidars and 3D lidars. With the cost, I'll say depth cameras are cheaper, 2D lidars are costlier, and 3D lidars are much costlier. Okay, so and one more thing is lidar market is diluting. The lidar market is diluting is nothing but most of the companies are buying. Actually, when we started, if you are starting this service robo industry or mobile robo industry 10 years back, you would have only 2 to 3 lidar manufacturers. Now there are n number of lidars coming in different places. Even maybe there are more Chinese companies have been doing a lot of lidars. Not only Chinese companies, Japanese companies and Korean companies have started manufacturing lidars in a large scale. So because of which the lidar prices are getting very low. So and the autonomous market is growing in a bigger scale. So I think I have addressed this. Select the right one which suits you best. One thing is you have to make sure that the total area is covered. See, you have to plan it wisely. There are mostly the lidars would have the field of views. Some lidars will have 360 degrees, some lidars will have 270 degrees, and some lidars will have a vertical field of view. Say for example, it will have 16 channels. Say for example, it will scan from minus 16 to plus 16 degree. So it means it will can scan only the 32 degree layers. So based on all these things, we have to make a wise combination, and we should not, there are some blind regions, that is immediately just 1 centimeter before the lidar or 1 centimeter before the depth camera, you will not, the whatever obstacle you place, that will not be seen while the data will not be captured. So you have to consider these blind regions, and you have to ensure that the total region is covered, because these lidars and depth cameras are the safety layers of your service robots or mobile robots. So based on this depth camera, 2D lidars and 3D lidars, based on the selection only, if suppose you left a path hole, or if you left some blind spot between two sensors or two lidars, or between a depth camera and a 2D lidar, there is some small blind spot. Even if some person is standing and if this robo hits, then it should be a bigger problem. So in case of the robo industry, one of the key thing is safety, because whatever good things you have done or whatever service you are offered will not be remembered. If suppose one falls or one accident you make, that will be remembered forever, and that is where the newspapers and other people make this a buzz, and there would be even we know several companies which, because of the safety critical issues, they have closed the companies. So it may go up to that. So depth cameras and lidars are the vital thing, and it has to be selected with proper proper planning should be taken, and ensure that there is no blind spot between the scanners or lidars. So next thing is a basic lithium maybe the batteries, which are the power, which are, I'll say, the blood and blood or muscles of your robot. So basic power calculations. So simply what is expected is simply calculate all the powers required by the devices. Say for example, if you're running a 400 watt motor, the power is 400 watt. So if you're having, even though you run it at 50% or if you run it at 20%, 40%, please consider 400 watt, and simply consider the processor's wattage. How to calculate wattage would be, mostly you'll get it from the data sheet or something. Otherwise, simply multiply the voltage and current of the existing power adapters, maybe the power adapters of the processors. So that would give us the wattage. So mostly we'll calculate all the wattages together and put those wattages and equate it to the power of the battery. So battery, how to calculate power of a battery? Power of a battery is nothing but voltage into, normally the batteries come with they'll say 48 volt 20 ampere hour. So this is how they specify the battery specifications. They have ampere hour rating. So simply 48 into 20, that would be the battery's wattage. So say for example, you have 500 wattage of power consumption. To have 4 hours of operation, you have to look for 200 wattage of batteries. Okay, so these are the simple calculations behind it. So this is a simple P equal to VI formula. That's it. Since it's a DC, it's a VI only. So it's a very easy to calculate if you know the voltage and current rating of all the appliances and the battery. So it would be easy. So that's a simple formula calculations. And what are the batteries available? So it is lithium ion, lead acid, LiFePO4, and LiPo batteries. So if it is, what is lithium ion batteries? Lithium ion batteries are maybe lithium ion, lead acid, LiFePO4, LiPO4, LiPo batteries. So I would say we cannot use all batteries for all applications. Every battery has its own application. Say for example, lithium ion are normally used in your cell phones and other things, and LiFePO4 and lithium ion batteries are preferable for service, maybe mobile robots. We prefer lithium ion and LiFePO4. Lead acid also we prefer, but the size and weight is huge. Because if you increase the weight of your things, therefore you are compromising on the payload carrying capacity of the robot. Say suppose you put 100 kgs of battery already, then the payload capacity would be, say for example, if you're having a robot with a payload capacity of 150 kg, and if you're putting the battery itself for 100 kg, then the payload is 50 kg. So lead acid batteries are huge in size and huge in space, and so because of which we prefer lithium ion and LiFePO4. So lithium ion and LiFePO4, what is the difference between lithium ion and LiFePO4 is nothing but lithium ion cells are fire retardant. Like it can be a burst, there can be a fire accidents, or lithium ion cells can burst, whereas LiFePO4 are better in terms of safety, and they are easily certified. Lithium ion batteries are not easily certified, whereas LiFePO4 is not that maybe they are easily certified, whereas lipo can be used in drones and wherever you require current sucking application. Say for example, you wanted a starting current to be the highest starting current, so where you require a discharge of 20 to 30 C charges, there you can use lipo batteries. So lithium ion, lead acid, and LiFePO4, lipo. So all these things, every cell, for example, if you are considering lithium ion battery, every battery, lithium ion, LiFePO4 and lipo batteries are made up of small cells. They are not made as a single cells. So for example, lithium ion, normal voltage would be 3.6 volt, maximum voltage would be 4.2, minimum voltage would be 2.8. Below, if you discharge beyond 2.8, the cell will get damaged, and you cannot charge beyond 4.2. So what does this, suppose if you wanted to have a 48 volt, what does this, the batteries are arranged in a series and parallel combinations. So if you arrange the batteries in series, the voltage gets incremented. Say for example, 48 volt battery. Say for example, if you have 3.6 voltage per cell, so it is nothing but 48 divided by 3.6. So that would be the average voltage or the nominal voltage of the 48 volts. That many lithium ion batteries are kept in a series. For example, if you want 20 ampere hour, for example, one cell has 500 milliampere hour rating. So then you have to place 4 cells in parallel. So simply it is nothing but when you place 2 cells in series, voltage gets added. When you place 2 cells in parallel, current gets added. So by using the serial parallel combination only, the batteries are made. All these battery packs which are shown in the diagram are not single cells, are all a package of smaller unit cells. For different current carrying capacity and different batteries. Say for example, if you see the Tesla car, which is one of the maybe the highest innovation happening in the EV vehicles, they will have the bottom chamber is filled with small lithium ion cells. The total circuit is powered by lithium ion cells. Okay, so this is one thing. And right charging circuits. So the BMS decides a lot of things, so we have to select the right charging circuits. And next thing is method of charging. So every lithium ion, lead acid, LiFePO4, LiPo, everything has its own charging methods. Don't simply connect with SMPS and try to charge all batteries. That is what most of the battery vendors would recommend, but it's us who have to ask him exclusively, and then you have to get a charging how to charge and make sure that we know lithium ion batteries are charged using the lithium ion battery chargers. There are some because lithium ion and lead acid do not have the same pattern of charging. So constant current charging method is preferred, not over the constant voltage method. SMPS supply constant voltage, not the constant current. So constant current methods are used in battery charging technologies. So we have to select the right method of charging instead of relying on the SMPS. Next thing is GPS and beacon systems. So apart from this wheel odometry, we require a localization in this real space. Say for example, how GPS is able to localize every person in the globe. Similar way, if you wanted to locate ourselves in an environment or in a map, localization is must. So GPS would be the best option to localize, but in case of indoors, we will not be getting this GPS points. So in those cases, we go for a beacon systems. So first we will discuss about GPS. So normally the accuracy of GPS is too high. That means it will be around 6 to 7 meters. Say for example, if you open a mobile and if you spot a location, or if you see find your current location, the blue dot will be somewhere in, maybe it will be around to your next of your street. Slowly after your continuous checking, or if you're waiting for 2 to 3 minutes, this position gets more and more accurate and comes to a right point. So this is because of the AGPS. AGPS is nothing but almost all of your cell phone towers are geolocalized. So the cell phone tower knows its exact latitude and longitude. So based on this current latitude and longitude data, this error corrections are happened using the cell network, and then we are getting the more precise location in mobile phones. Similarly, we have an RTK GPS. The RTK GPS is two parts. One is a base and another is a rover. So the base part, it's so simple. The base and rover has to be placed in at least in a 5 kilometer radius, because whatever the base is, almost how GPS is calculated is like the satellite signals will be received to the chips. So based at least 3 to 4 satellites is required to get the precise positions. So what does this GPS does is it pings with the different satellites and put a circle. The interpolation or the intersection of these circles will be the GPS locations. So normally the agenda is like the base and in the case of RTK GPS, the base and rover would be in the same location, say at least in the 5 kilometer radius, so that the both rover and base will be pointing to the same number of satellites. Say for example, if base is getting 10 to 15 satellites, mostly the rover will also be getting the 10 to 15 satellites. So base knows the correct exact location, like how we are localizing the cell phone towers. The base is expected to know the current locations. So based on the location data of the current data, it calculates the error, how much error it has, and based on this error data has been passed into the rovers. So the rover automatically adjusts this and then calculates. This is how RTK GPS works. So next thing is BLE, UWB, Wi-Fi, and ultrasound beacons. These are simply smaller beacons which are present across the buildings, or this is mainly for indoor, whereas GPS is mainly for outdoor. So if you're selecting a robo for outdoor, then you have to rely on GPS. Whereas when you're selecting on indoor, you can rely on, there are a lot more mechanism to localize. So these are the popularly used mechanism to localize. Okay. So the next thing is the highlights of robot operating system. So the robot operating system, it does most of the things for you. So the robot operating system, say for example, I will explain this part here. So maybe I'll take this part and I'll explain. So navigation. So navigation is nothing but first of all, if you wanted to say, for example, this is one map. For example, you have an obstacle. So your robo is currently here. So you wanted to move from here to here. Maybe here. You wanted to move from here to here. There is an obstacle here. So because of which this robo has taken a turn like this and it has come here. So this is what the plan. Maybe first you will say this is the current location, because based on the localization, we know the current position. From here, we wanted to move here. So this information, the goal from where to where is published by the goal. So this goal is published to the navigation stack. What does the navigation does is it plots a shortest path between this path to this path by avoiding the obstacles. So this is the global planner. What does the navigation? Okay, the global planner is then based on this global planner data, a path is created. So currently the robo, what it is expected to do is it is expected to follow this same line and reach this point. The local planner, maybe the laser, IMS, IMU, GPS, odometry. What is IMU? Is nothing but inertial measurement unit. We get the IMU is the combination of accelerometer, gyroscope, and magnetometer. So IMU, because of the presence of IMU in your mobile phones, we are able to know which position it is. Say, for example, if you are opening it in the front portrait mode, the view you are able to view in the portrait mode. If you are in the landscape mode, automatically the screen switches to the landscape mode. All this is because of the IMU. Similarly, to know the latitude, know the orientation of the robo with respect to Z-axis. Say, we call it as So with respect to Z-axis, know the position, we get IMU. GPS is to localize. Odometry is from wheel odometry, or it can be anywhere. So laser data comes. So based on this local cost map, there is a global planner. Global planner plans the path for the global points, whereas a local planner, there will be a smaller area surrounded by the robot. So we can define the area of this point. I mean the area surrounding the robot. So what does is that based on the obstacle, suppose suddenly an obstacle comes here, what does this robot does is it will try to see after moving to this point, maybe while moving itself, this robot, based on the laser and other things, it evaluates a cost map. Cost map is nothing but, say for example, if you have 8 points like this, say for example have 9 points like this, if your robot is here, what would be the cost required to move to this point, or what would be the cost required to move to this point? So every point from this point, every point cost is evaluated, and then to which point the cost is low. Say for example, if suppose an obstacle is here, so or if a motor is facing this side, if you want to go to this point, you need to turn to this point and then you have to go to this point. So but in here you can directly go to this point. So based on this, the cost is low for this point when compared to this point. So like this, the cost map is evaluated, and then it goes to okay. So here the cost map, local cost map is just a planner which calculates the path to it. So the navigation stack follows the path guidance, and the goal is given from this guidance stack, whereas navigation takes care of the motion, whereas perception is nothing but all the laser data and the sensor data are fed into navigations. This controller is nothing but based on we will get an angular and the linear velocity, how much this robot should move in this direction, or how much the angular velocity it should turn. So based on the angular and the linear velocity combination, the controller, we know the motors can accept only in RPM, right? So all this angular velocity and other things are converted into RPMs and fed into the motors. So this is how the whole actually this most of the things are happen using ROS. So just we have to do select the parameters and what to tune. Just a tuning is enough in this, and in this total part. Maybe it seems to be a bigger thing. Almost everything happens at the background. We wanted to tweak, we wanted to tune and make sure that we give the proper goals and other things. That is where we expect in ROS. So here we have ROS. Oh, be sorry. So ROS, and then ROS is the major platform. In that, Gazebo is the simulation platform where instead of going for a physical environment, you can test everything in your simulation itself. RViz is the live visualizations. So this gives you the robot's view, like what is it going to do next, or what are the things it is doing currently. So all these things would be captured in RViz. So these are the few platforms available, plugins available within ROS. Okay. So next thing is ROS, robot operating system. It handles almost everything. So next thing, that's it. Maybe I'll open for questions so that we can discuss. If you want me to explain anything in more detail, I can explain you. Maybe from my point, whatever I wanted to convey or whatever the mistake we made, I think I have delivered to some extent. Maybe I'm open for questions so that I can able to solve. I mean, I will able to answer and give you a better answer. Any questions?
Sir, it was a wonderful presentation, sir. Very nicely you told your presented thing. We enjoyed your presentation. Really, you brought back us to our ME manufacturing technology, where you studied robotics. You brought all those things. Thank you. We enjoyed your program. Really. I have a question, sir.
Okay.
Now we are in the COVID situation. Have you supplied any robots to service that healthcare industry, sir? That is hospitals and all?
Yes, sir. Actually, we have developed a UV-based autonomous mobile robots. Actually, we have developed a prototype, and we are in the process of manufacturing to the healthcare industry, sir. Actually, maybe we have delivered this robot for ESI hospital in Coimbatore here. It was there for 1 week or so, and maybe people feel difficult to operate. Maybe with this COVID point, and one point is UV based autonomous robo. We got an order and we are in the process of manufacturing, sir. We are supplying to Singapore, and then we are supplying to India.
Yes, okay. So wonderful and excellent presentation. Thank you very much. I really we enjoyed your presentation. Thank you.
One question: what is the life of Mr. Muthu? What is the life of a robot? Like a home trade, just a small robot. What is the life?
Sir, we are giving warranty for 1 year, sir, but we are expecting, maybe we have selected all components to withstand for 5 years. Since when we are supplying for a country like Singapore, we require the utmost the quality. So in those case, we need to maybe traveling and doing a service over there at Singapore is quite costlier. So what we do is we select the better components which at least suit for 4 to 5 years of lifetime. There are some mechanical wear and tear problems. There would be something in belts. There would be some there we require a service for every year once, sir. So at least we are doing 6 months once a service.
Okay, thank you.
So we are changing almost all the wear and tear parts every 6 months once, and if it is not even worn also, we are changing currently now.
Maximum it will be only 5 years.
Maybe we have not extended beyond that. We have not thought of beyond 5 years currently, sir, because technology is totally changing, and I'm not seeing a hope. Maybe after 5 years, the robot industry would be totally a change industry. So the technology would be, for sure, it would be an upgraded industry. So for a hardware like this, 5 years should be more than is what we thought and we have made. Maybe we have to relook if we felt 5 years is small.
Thank you.
Mr. Muthu.
Sir, have you supplied any robots for industry 4, sir? No.
Actually, for industry, we have maybe for industry we are making currently, sir. For logistic purpose, we are making currently. So even the same robot which we are developing for logistic industry, we are trying to supply it for material movement within industries.
Right,
Actually,
sir. Thank you. Thank you.
because of this COVID-19, few of the orders which was to be closed has been on hold now.
Thank you, sir. Thank you.
Mr. Muthu, what is the cost of one small robo and what is your AMC charge?
Sir, actually for this hotel robots, based on the volume, we price it, sir. Normally, it would be costing around 6 lakhs currently with an autonomous capability and other things. The AMC charge would be around first year would be a free AMC, sir. Followed by the subsequent years, we'll be charging around 5 to 6% of it, sir.
Okay, thank you.
Hello, sir. I am a graduate engineer. I just want to know about onboard processes and things like that.
Okay.
Can you talk more about that? And also, I have another question about video surveillance. You said you are supplying for Singapore and all. I just want to know, like, how do you get the data for you said like we analyze the surveillance and say if there is a potential threat. So for to analyze that, like you need more repository of data to see to video for a video analysis purpose. So where do you get your data?
Actually, the most of the data's training data set we create. To mostly because we have that much number of cameras with us, so we get the data live, and in some cases we rely on the open source data sets which are available in Keras, Kaggle and other things, right? So we rely on the data sets which are available in open source, and then we in some cases we buy data sets. If there is an exclusive data set, say for example, if you are looking for a number plate recognition, now we have about trained around, mostly we have crossed around 10 lakhs vehicles within, maybe we have around trained data for 10 lakh plus in the context of Singapore. Say for example, if you wanted to switch the same context to some other country, say for example Oman or other Malaysian and other things, so in those cases we try to train, maybe we'll take some more time to train, right? So in the meanwhile, if you're getting some data to at least to some extent to improve, to have a better accuracy, we try to purchase data sets which are already available. If no data sets are available, we allocate, we have a separate team for annotations. They do all these annotations and we do it, and we have a supercomputers and we have cloud-based platforms to train the data sets. So we do training regularly. Maybe every day there is a machine which runs training. So we have a separate machines to run those data sets in our office premise. So we do it, and sometimes if it's a huge data sets, we go for a cloud-based trainings.
Also about processes and I am more interested in learning about ROS. Like, what would be a starting point to do that, sir? I've already worked with Arduino and stuff. Like, I've done like small IoT projects using mobile. Connecting Arduino and mobile applications and all. I would like to learn about ROS and stuff. What would be a starting point, sir?
So for starting with RAS, right? So you can, there is a website called ras.org. In that itself, ras.org/tutorials also already available. RAS tutorials, if you Google it, you will, the first link what would be coming is the RAS predefined tutorials. So you need not to rely on any big books, or you need not to go join any crash course. That would be not be my suggestion. Please go through the tutorials. Actually, RAS is very simple to learn. But however, implementing the complex algorithms in RAS is it comes based on your experience, not by teaching. So RAS is RAS is a methodology to handle robots. RAS gives you, simply there is publisher subscribe. I think when you are dealing with mobile application and Arduino, you would have known about the request response model, right?
Yes.
So you would have been known about the request response model. There is the most of the RAS application has a publisher subscriber concept. So publisher subscriber concept is nothing but like how when you subscribe to similar to MQTT. The same architecture is RAS architecture, where in the RAS architecture you can do not only publish subscribe, you can do request response. So these are all like mechanisms. These mechanisms are implemented with ease. So RAS is not a place where it's mostly deal with robots. Nothing. It's not like that. RAS is a framework which is a collective and combination of all this, like request response model, publisher subscriber model, and even you can have, there are some action clients and there are some client based nodes. there are some similar concepts which you are learned in a different pattern. You will learn it with the different names here. That's it. So these are the mechanisms, and the ROS provide a way how to organize this data into an organized format. So this is how ROS helps you. Actually, the ROS, maybe most of us think ROS, by learning ROS we'll develop a robot. It is not that way. ROS is a mechanism based framework where you can use the mechanism, and then you can solve those problems problems which are facing in the robot. So you need not to go with any specific processor as of now when you're starting. Put your change your Windows PC into Linux PC and start working on it. So that would be the easiest method with a low cost solution. Whereas Gazebo and Arvis are the platform where you can really simulate to the greater extent. Even before developing a robo, maybe mechanical team and electrical team will take some time before developing, right? They will consume some time. So in those times, what we do is we develop, we create those real environment and we test it with the simulation, and then only we will move to the real-time deployment. Then only we'll feed the algorithm into the code. To validate your algorithms, to validate your process, Gazebo would be more than sufficient. To real-time test the physical parameters, the tuning, the navigation.
நீங்க 13 மினிட் ஒரு இமெயில் அட்ரஸ் ஃபோன் நம்பர் கொடுத்திருக்காரு, கேட்டுக்கலாம்னு சொல்லலாம்னு தோணுது எனக்கு. நீங்க 13 பண்றீங்களா?
Okay, so that would be the easiest method.
7:25.
So that would be easy to understand.
Thank you, sir.
That
Thank
would be,
Sir, I have one more question, sir. Sir?
Yes, sir. Yes, sir.
Yes, sir. Are you targeting the domestic robo, sir? That is
Currently,
for
yes,
age-old people. There may be service required for them, for those people.
Actually, currently, maybe we are maybe that is our one of our, that is a plan is there, sir, but we have not taken this into consideration. Currently, we are focusing on security patrolling, and then food deliveries within a closed premises. Say, for example, if you are a closed campus, say, for example, if it is in a Bell campus, there would be a food delivery within a Bell campus. So it is like that. So like this, currently we are focusing, sir. For elderly support, currently what we are doing is we are creating a virtual security guards in Singapore. What we do is instead of a security, we create some robots. It does the role of security. Say just an answering, or most of the thing would be like a simple questions, right? What you will ask to the security. So where to go, how to go, whether you are open or not. So some basic questionnaires we will be trying to solve. What are they able? Maybe that is what we are creating currently, sir. For elderly, we had a plan, but we have not implemented to a larger extent currently, sir.
Right, sir. Thank you, sir. Thank you.
Thank you, sir.
Mr.
Thank
Muthu,
you, sir.
I am Ramdas.
Yes, sir.
Actually, we are going next month, September 12th. We are going to do one day program in AI, artificial intelligence.
Okay, sir.
Morning 9 to evening 6 o'clock.
Okay, sir.
With LNT.
Okay.
So at that time, can you able to do what are all the your product having, and then what are the applications, all those things? Can you make it as a
maybe maybe I'm not that good at machine learning and deep learning, sir. My focus is on mainly on robotics. Maybe I will loop our machine learning and deep learning team who are available here. Maybe the team leads of those teams into this, and then I will able to, maybe I will connect you, sir.
Okay. Okay, I call you in the
okay, sir,
over phone number. Okay, thank you.
Thank you, sir. Thank you, sir. Thank you for your wonderful lecture, sir. On behalf of IEI TLC, I thank you for your wonderful lecture. Regarding next week lecture, that topic of next week lecture is virtual instrumentation in R&D world. That speaker is Dr. S. Uday Kumar, Assistant Professor, Department of Mechanical Engineering, PSG College of Technology, Coimbatore. So I request all of you, please participate in next week lecture program also. Now I request Engineer Samidas, former IEI TLC chairman, to propose vote of thanks.
Good evening, gentlemen. It was our organization and all tips for startup for in this area. I wish to thank on behalf of IEI TLC and IEI Tamil Nadu State Center, Mr. Muthu Vengaliappn for his wonderful lecture and for sparing his evening with us. And also I should thank our PA chairman, Mr. Selvaraj, Mr. Karpswamy, our current chairman, Kumaresan, and other participants for their valuable time. went in this lecture. Finally, wish to thank Mr. Kannan, also Honorary Secretary, Tamil Nadu. Thank you, Ananda.
Thank you, sir. Thank you.
Thank you, sir.
Thank you, Mr. Muthu. It's a wonderful program. I wish you all the best in your startup. Thank you, sir. Thank you.